Hello guys, so welcome again to experiment number 4, Archimedes principle. Now we'll be doing the part B of this experiment. Okay, now we'll be computing for the density of liquid. On the first part, we computed for the density of solid, in which we use also the principle, the Archimedes principle. In this one, okay, we'll be also using the Archimedes principle plus we'll be using the hydrometer to measure the theoretical volume of the density of liquid. Okay, the formula to get the density of liquid is simply the difference in the weight of the metal sample in water and also in air. So that will be weight in air minus the weight in the liquid. So the liquid can be the Sprite or the column, and then the other one is it can be also water, divided by the value of acceleration due to gravity multiplied by the displaced volume. Okay, for the displaced volume, we need to get the initial volume and then the final volume, then just get the difference, that is the displaced volume. Okay, that is the displaced volume after placing the metal sample inside the graduated cylinder. In the first part of our experiment, we use beaker, okay, but this time we'll be using the graduated cylinder. But the same procedure, we need to compute or to measure the weight of the metal sample in air and also the weight of the metal sample when the metal sample is immersed in the liquid. And then in addition to that, we need to compute for the volume of the liquid space, and that should be divided or multiplied by the acceleration due to gravity. Okay, the first thing I will do is I will be measuring first the theoretical value of the density of liquid. I have here two columns again. The first column or the first row. Okay, we have two rows here. The first row is allotted for water, so the first liquid is water, and then the second liquid is we use this one. Okay, so I would like to thank this Sprite, okay, for to be the sponsor of our experiment. But anyway, the second row is for Sprite. I will be placing here Sprite to be specific. Okay, I use on the first experiment we use, on the first part we use two metal samples. So we just need to select one metal sample from the two metal samples. So in the second part, I choose the brass as our metal sample. We already computed or measured the weight of the brass in air and also the weight in of the brass in liquid. So we can just copy the data, the first data to the second column or the second table. On the first table, okay, the weight in the air is 130,330 dynes, and then the weight in liquid is 115,520. So this one is only for water. And of course, for Sprite, we will have a different value for the weight in liquid, okay, because different types of liquid will give different value of the weight of the metal sample in that specific liquid. So I will just copy the weight of brass in air. So that's 130,330. So 130,330 dynes. This is also 130,330 dynes because we'll be using the same metal sample here. Weight in liquid, in first liquid. So the first liquid is water. So in our first experiment, first part, so the weight in liquid, okay, in water is 115. So I will be just copying the value here, 115.20. And then the volume is, we need to compute for the volume to measure the volume. And the theoretical value is, we need to use the hydrometer. Okay, so this one is for water, this is for Sprite. So for us to measure the density of liquid, we just need to look at the lower meniscus. Okay, so if the lower meniscus is on this line, okay, so the reading of the hydrometer is somewhere here. If the lower meniscus is here, so meaning the reading of the density is 1. So if the lower meniscus reads here, so this is 0.90, something like that. Okay, so meaning every line is equivalent to 0.01. Okay, that's 0.01. Every line here is 0.01. I'll be placing the hydrometer here. That's it. You have to look at the reading on the density. Okay. So that is equal to 1. Okay? So the theoretical value of water, the density of water is, that's 1. Yeah. Yeah, that's constant value, but based on our hydrometer, it also gives 1 as the value of the density of water. So I'll be placing the theoretical density of water. So that's 1.0 gram per cubic centimeter. So gram per cc is gram per cubic centimeter. So we need to compute for the, or to measure the volume. Okay, so we need to look first at the initial volume of water. So the initial volume of water is around 400, that's 450. Okay, that's 450. Okay, that's the initial volume. Now I'll be placing the metal sample. Okay, obviously there should be displacement. There should be displaced liquid. Okay, from 450, it becomes 400. So this is 475. So meaning every line is 5. So 450, 450, 455, 460, 465. I guess that's 465. Okay, so the reading there is 465. Initial volume is 450. The final volume is 465. So 465 minus 450 cc. So that's 15. Okay, this 15 cc. So the volume here is 15 cc. Okay, let's use the formula. Okay, the difference in weight. So that's 130, 330 minus 115, 520. Okay, divide by acceleration due to gravity, which is 980. Okay, that's 980. Okay, then multiplied by 15. Okay, the value here is 1.007. 1.0007 or 1.01. Okay, so let's use two decimal places. So 1.01. So the value here is 1.01. So obviously 1.01 minus 1 is 0.01. So 0.01 divided by 1 is 0.01, of course, times 100 is, we have 1. So the percent error here is 1%. Okay, this is for water. Now let's change the liquid. Okay, replace this one by the second liquid, which is Sprite, okay, or cola. Okay, so we have the Sprite here. Okay, now I'll be measuring the theoretical density of Sprite. Okay, let's see if this is greater than or, so that is the one value. As you can see, guys, here's the one value, and then as you can see on the lower meniscus, the reading is greater than 1. Okay, greater than 1 by how much? Okay, here guys, this is 1, 2, 3, 4, 5. Every line is 0.02. Every line is 0.02. So I guess that is on the 1.02, 1.04. I guess that is on the second line. Okay, that's 1.04. 1.04 is the theoretical value of the density of Sprite. Okay, so that's based on the reading using the hydrometer. Again, we have 1.04. This is the theoretical value. Okay, again, the theoretical value is based on the measurement using the hydrometer. So we need to get the weight in liquid. So let's just look at the initial volume. So the initial volume is 400. Okay, that's not exactly 450. Okay, I'll be adding just a little portion of the Okay, now this is 450. Okay, the initial volume is 450. Okay, the weight in the air of brass is 130,330. Now I'll be placing here the brass. Okay, immersed in cola. Okay, now let's look at the volume. Okay, the volume here is 1.1552. So 1.1552. So they have the same value with water. Okay. Okay, so that's 1.155. No, it's still changing. So let's use. Okay, so that is also the value. 1.11. Okay, so that's also 115,520. Okay, that's also the reading. So here the volume now here is 450, 5, 10, 15. I guess that's 20. Or at the middle of the mid. Okay, so this is again 5, 10, 15, 17.5. So the displaced volume here is 17.5. So this is 17.5 cubic centimeter. So let's compute for the experimental value. So the same formula. So 130.3 again 130 330 minus 115,520. Hopefully the percent error is less than 10. Okay, divide by 9.8 or 980. So 980 multiplied by 17.5. So the value is 0.86. Okay, what happened? So I guess I need to perform again experiment because the density here is 0.86, but according to the hydrometer, the reading is greater than 1. So that's 1.04. So I will be checking again the value. Okay. Okay. Again, I'll be repeating the experiment. Okay, the target is the density should be more than 10, but based on my first data, it's less than 10 or it's less than 1. Okay, I just need to be more accurate here. Okay, based on the reading, they have the same value. Okay, of course, the weight in air, it must be also 133. Okay, 1,330. Okay, that's also the same. 130, 330. I'll be placing this in hydrometer or in graduated cylinder. Okay. One six two nine one 1.6291. It's fluctuating. Okay, the reading is really 1.1552. So that's still the reading. Okay, I guess I just need to get the Okay, this 5, 10, 15. Okay. This 15. Okay, if that's 15, meaning we'll be also computing for the experimental value will be also 1.01. Okay, this is 15 cc, then this is 1.01. Okay, if that's 1.01, 1.01 minus 1.04. Okay, divide by 1.04. Okay, so we have times 100. So the percent error is 2.88. So this is 2.88%. Okay, again, they have the same volume of the, in terms of weight in air, the weight in liquid, and then the volume is also 15. Okay, that's the same with water. Okay, so we have the experimental value 1.01, but in this case, the theoretical value of Sprite is 1.04, but still we got a percent error which is less than 10. Okay, I'll be computing for that again. 1.01 minus 1.04, okay, all over 1.04, okay, times 100. Okay, that's 2.88. So this is how to perform the second part of Archimedes principle. Okay, thank you so much, guys. Okay, anyway, you need to also answer the guide questions. Okay, we have here 4 questions. What will happen to the object if the density is greater than that of the fluid? Then what will happen to the object if the density is equal to the density of the fluid? So what will happen to the object if the density is less than the density of fluid? And then how do you relate buoyant force to the density of materials? So your answer might be the object may sink, may float, or it may be stay on the bottom or stay on floating or whatever. And then of course the number 4, you need to use the formula to get the relation between the buoyant force and the density of the material. Okay, thank you so much, guys.